Yeah, our last talk for
I think like I went Blizzard, but I also went.
Quin Carter,
I was wondering, should we
software engineer at
I
Capital
mean, I went
One.
Blizzard.
Oh, no, you didn't.
I went Blizzard.
Wow.
I think that's just
First off, how's everyone's presentations been, or how's all your things been today? Have you done everything, or
yeah.
what's your first talk of the day?
Just
Okay, everyone's just like, come on, finish. Happy hour's coming. Let's just go get a drink, and I can't wait for that. So yeah, I'm very excited to be speaking here. Very honored. This is actually my first external conference to be speaking in. I work at Capital One. I have been there for about 6 years now. Just a little bit about me. And I speak at Capital One all the time internally. Been like talking about different things, front-end development. I'm a front-end developer, JavaScript developer. I do a little Python, I do a little Docker, I do a little everything. So, but I find my passion with front-end. So a little bit about me here. You see a few things on the screen. I'm at Quin Carter on like everything. Follow me. I post about only coffee on Instagram, so if you don't like latte art and you don't want to just see people going like this with their lattes, then don't follow me, but please follow me. I'm trying to get to that 1,000 so I can monetize. Also, you see below, I have 3 icons here. One of them, the little house, that is Home Assistant. If you're not sure what that is, I'm going to plug it real quick. It's a free and open source platform for home automation. You can run it on a Raspberry Pi. And it's actually so free and open source. They're founded by the Open Home Foundation, or funded by the Open Home Foundation, and they are built on web components too on their front end and Python for their back end. But you can self-host it. It's very much like I am owning my stuff, so that's what I really like. I know it's kind of a cliche, but I like movies. You'll see that in a little bit. Movies are like the thing I love the most outside of work to just consume, and TV shows are also great. You have to really invest time though, and I don't really like having to invest 6 years of my life to then have the show canceled, and then I'm like, come on, man, he died, but he was alive. So yeah, I like movies because you can view a person's entire story in like an hour and a half, and that just kind of gets your thing on, and then you can just move about your day. And again, I like coffee, almost too much. I've had a little too much today. I'm kind of shaky here. All right, so we have a lot on the agenda today, and I have like 68 slides that I've reworked 3 times in normal speaker fashion. Right before this talk, I was still editing my slides. So I'm going to go through what we're going to go through, and then we're going to talk about it. And we can be interactive here. We can ask questions. Just know that you're holding everyone up for happy hour. So if you have any questions, just that's going to be a thing. Just blame that person, don't blame me. So first off today, we're going to talk about performance mindset. In order to talk about workers, you have to first talk about a performance mindset. And that's really important. We'll dive into that first thing. We're going to talk about the main thread. Just out of curiosity, how many people here have worked with web workers, service workers, shared workers, worklets? Great. Okay, we actually have hands in the room. Okay. This is not an advanced talk only, so if you haven't worked with workers, don't worry, you're not going to be lost. I start at the top and I work my way in from the novice user to the advanced user. Workers as a concept, not super hard to grasp, but we're going to have to go into that. We're going to talk about what is a worker. I'm not going to tell you right now because I'll just spoil it. Worker implementation, I'm actually going to show you some code. And workers spawning workers, spawning workers, spawning workers. It's like, hey, look at this, look at me. I can go spawn everything, respawn, respawn, respawn. Yeah. And we're going to talk about workers and micro frontends. How many know what micro frontends are? Anyone? Oh, awesome. We got lots of hands in the room. If you're not implementing workers and you didn't raise your hand on the first one, then you probably need to follow this. We're going to talk about do a little demo, and we're going to look at some other considerations. Specifically around workers and micro frontends, and I might slightly touch WASM because it's been touched a lot today, and if I didn't, it'd be weird. Okay, so here's a hot take. I use SSR, I'm on Next.js. I don't need a worker. False. You still have to send data to a client. So you do need a worker. You need to process large data sets on your client side sometimes. It's not all server-side rendering. Next.js, 9 times out of 10, unless you're doing React server components, will only actually give you your initial page load. And that depends on if you're doing hydration, you're doing like SvelteKit, or you're doing Astro, or you're doing one of those like server-side render first things, or you're building static sites. Those things may not be as applicable because you're rendering basically raw HTML. And this is specifically, you have lots of JavaScript on your page. This is why you will want a worker. You have lots of complex calculations. If you're doing raw HTML and you're just doing static sites, like seriously, like that's what SSR gives you. And if you're rendering static sites, that's where you may not get workers, get the most out of them. But it's JavaScript. So again, you want to perform background tasks. And you don't want the user experience to be impacted at all. So you want a buttery smooth animation, like what Moment talked about earlier. If you're trying to do buttery smooth animations and you don't just have HTML and CSS on the page and you're running JavaScript, you have a lot more to worry about in the browser with JavaScript, especially because we write, how many people here use React? The whole room raises their hand. Okay, Angular. Okay, what about web components? Looking over here. Okay. Okay, all that uses JavaScript. So those things are very, very heavy tasks. The browser it's gotten smarter over the years, and it's gotten way better than it was back in 1998 when JavaScript was founded. I'm not going to go back that far. Trust me, I don't have time. So we're going to talk about web performance first, and this is very, very important to consider because web performance impacts your users. And your users are your customers, they're your people that make you money. If you give them a bad performance, they're not going to come back. And they're going to bounce, and they're going to be like, oh, that site sucks, I'm never going to go back there again. I'm going to go to this other one that makes a similar product, but the site renders better, and I have better experience. So to help me do this, I am actually following something from web.dev. It's called the Rail Guidelines. How many people have heard of Rail? No? Okay. Go look it up on web.dev. I got all this information from there, and they go more in depth. I'm going to touch on the service level on this. I don't have time. I could do a whole talk on Rail. Response, animation, idle time, and load time. Response time refers to the initial load, okay? You have 50 to 100 milliseconds to actually get this response time to happen, okay? Your focus is on the user. You want to process events in under 50 milliseconds. Our budget is 100 milliseconds. Okay, 1,000 milliseconds is 1 second. That's not much time at all. Okay, and this has a lot of impacts because we budget 100 milliseconds, but 50 milliseconds is what we go for because there's other tasks that happen inside of this process. You have to get idle tasks, you have a click event, then you have to process the JavaScript, you have to do the functions, and you have to just go through everything in the stack in order to make stuff happen. And this all has to happen like that to make your site run at 60 frames per second. I'm going to say that a lot, 60 frames per second. Because as a human being, our eyes, we'd see something at 55 frames per second, 40 frames per second, 10 frames per second. It's going to look like this is happening on your site. And it doesn't look pretty to our eyes. We want it to look like fluid. I'm doing this because I'm shaking, so anyway, animation is next. So we want to provide things to the user to give them a better experience. Our animations, again, need to run at 60 frames per second. So each frame has to happen in under 10 milliseconds. We're going to dive into that a little bit later, but our budget is 16 milliseconds for 60 frames per second to happen on a 60 hertz display. Asterisk. Idle time. This is the time that you take after the initial load of the page to basically defer your tasks. If you defer your tasks to this idle load time, you load initially everything you need statically. And this is a very good mindset to have. So basically, your index HTML should look dirty. And in a SPA application, your index HTML looking dirty, it's just like normally in Angular or React, you load your root component and then everything loads, and you really have to run all your JavaScript for that root component to then render. But on a mindset you take with performance and this idle load time, really, you just need something to load on the page to show something's happening to the user. And the user, when they hit your page, as a great example, you hit, I don't have Facebook anymore, but you hit Facebook or you hit Twitter or you hit GitHub. And those things all render like really, really fast. But if they take a minute to load, they show some sort of like skeleton loader, or they show and render some sort of animation on the page to show you, hey, something's happening. Yo, wait for me. I'm doing something, but something's happening in the background. Yeah, and you want to defer anything you can from that initial page load to happen like after that initial page load happens. So you know the little defer tag on your script, you can defer it until after DOM content loaded, and then after that happens, it will then execute. All right, and then load. Deliver your content in under 5 seconds. I know 5 seconds feels atrocious, but I'm not talking about time to first paint or longest contentful paint, LCP. INP is time to first interaction, basically. And God, what am I missing? FCP, MCP, LCP. It's like the 3 main Lighthouse scores that you focus on, that focuses on the initial page load, layout shift, and layout something. I'm drawing a blank right now. Basically, you don't want layout shift to happen either, which causes stuff to like push down the page. You push a button on the page and like goes. You're going to see layout shift on my demo because I didn't take time to focus on that. Okay. So in order to fully understand your performance of your end user, you actually need to test on devices that are not your M4 MacBook Pro or your gaming laptop that's an Omen computer over there. Sorry, I called you out. Where your single core performance scores are probably like, these are like benchmarks from Geekbench. It's probably, I don't know, in the 5,000 range or something like that for the single core performance. I listed multi-core here. That's important, but not very important because the web is inherently single threaded. It runs on one thread, which is kind of false, but not really. So you have the iPhone 16 Pro Max and the Google Pixel 9 Pro XL. You'll notice there's a huge difference, but the iPhone is just like bomb because they're Apple and they build hardware, and Google is a company that builds software that is trying to build hardware. And I have a Pixel 9 Pro XL in my pocket. I also have an iPhone 13. So these are current gen devices. You're not gonna have a problem with these devices. These aren't your problem child. This is the previous generation. So you have your iPhone 15, your iPhone 13, really, really not that big of a difference. Like, honestly, I mean, these are devices that will render buttery smooth no matter what. Okay. Then you have devices that are still in the market today that people buy. Us in the Western world and like people who can afford it, we are going to buy the flagship device. But those aren't your customers you should cater to. The customers you need to cater to are your low-end customers. Because there's customers out here who have devices like the Moto G 5G 2024. Still bought today. This was pulled from Geekbench 5 hours ago. Well, I guess 5 hours ago from this morning, so it would have been like midnight last night. But the single core performance is 846. I mean, that's not the lowest one that I found. But this is one that said 2024, so I could show it. That's also the one that was the same as the iPhone 7 Plus. Let that sink in for just a second. Do you know when the iPhone 7 Plus came out? Do the math. It was 10 years ago. So they're on a device on the Moto G 5G 2024 that iPhone users were enjoying on their processor. Like, oh man, this is nice. In 2016. Does anyone want an iPhone 7 right now? If you're an iPhone user, no. You want that 16, you gotta have that 120 hertz display. Yeah, it's a little ridiculous. It was announced in 2016 September, released in September 2016 across the globe. And there's a Moto G3, this processor single core performance is still at the same level. I know this is not a talk about performance, but I mean, I really had to gear it because people need to understand there's phones even worse than this that sell for $70 USD in India right now. They go for 6,000 rupees, and these are cheap phones, they're feature phones. But people are using them. It runs a modern version of Android-ish, modern-ish, and a modern version of Chrome. So they're running the modern web on this device. Do you know what the performance score is on this? Well, I have another phone too here. 2020, a little bit older, but it's still being sold. There were still scores released for this. These two are Right there. Okay. So to maximize these devices, go try and buy one of these. Seriously, like they're cheap. Like $70 American, and you can probably pick up one used for less. That was on a brand new site that I saw. Pick up a device, go try and load your site on it. And you'll be very, very surprised at how lacking your site is. Okay. So with all that said, that was performance. We're going to talk a little bit about the main thread now. And the main thread is something very, very important for JavaScript, because JavaScript was built around this main thread. And ignore the background, it's an AI generated image. I in fact think it says like Skolos or something like that. Like I don't even know what the words are on this. It's just, it looks cool. Yeah. All right, so what does it do? The main thread, like what does it do? Anyone know? No? Okay. The main thread is running your browser. So it has to do layout, styling, compositing, CSS, JavaScript, events. You're shoving all that down the main thread. And when you work in a single threaded mindset, let's go back. How do you think that device is going to handle whenever you have a 1 megabyte, let's just say 1 megabyte, that you're trying to shove down, and you have all this computational JavaScript that you're trying to just make work? It's going to suck. Let me tell you, it is going to suck. Another name for the main thread, I'm proposing, and this has been proposed by more than just me, but we call it the UI thread. Who else has anyone here done iOS development, Android development? Okay, you have the UI thread, Unity. I mean, you have your business logic and separate from your rendering, because you want your rendering engine to run separately than your business logic. You send commands to it, and it does its thing. In another thread, you're happy, you're go lucky, and you're playing Cyberpunk 2037. All right. And what can we as devs do about this? Well, we can use workers. That's what it's talking about. You can also do other things too. If you're like, ah, man, my project's a legacy project and I really don't want to optimize it. Okay, fine, we can't be friends. But we can do a lot more as devs. We can bundle, we can minify, we can do our best to write clean code, clean functions. We're not doing unnecessary iterations. Like your big O notation needs to be very slow. You can't be iterating over large objects. Like you just have to do things efficiently. If you're on a small app, I mean, you might not need a worker. But my hot take really is just workerize everything. So why not? It's just a design pattern that you have to put your mind around to work. So please consider the following. This is a Google image search. I throttled it down to a slow 4G connection and like a slow 4x, like a 4x CPU throttling, not as slow as it would go. I'm now clicking around on the page, trying to get stuff to happen. I'm thread blocked right now on this Google image search. You can't see what my network performance is, but I'm sitting here like, it's trying to load, and I'm like, why isn't it happening? What's going on? I don't show the end result because finally the page loaded, and then it popped up, you know, the sidebar. I didn't demo the other one, but I opened it on my phone, or I guess on a scaled down device, same performance. It took 6 seconds with a black screen, because I was on dark mode, with a black screen, and I didn't see anything happen. It was just loading for 6 seconds, and it wasn't doing anything. And then suddenly it loaded, and then I had interactivity. I could push on stuff. So I think that took about 6 seconds, maybe a little more. I think the mobile view is a little more optimized. I think they have like content visible true or something like that on their CSS, so you're loading less images at a time. But like, it was still a little ridiculous, and I couldn't have any interactivity right away, so it was still a bad user experience. They weren't running any workers on that site, and I checked. And I'm surprised this Google Images, I mean, they're supposed to be a thing. So this is going to be a timeline, and I pulled this from one of Surma's talks he did back in 2019. He was a developer at Google, evangelized workers crazy. Still, no one has adopted them, so I don't know what's happening. This is basically the main thread. I'm going to depict it here just how he depicted it. The main thread, this is everything that's happening. You're going to process events. You process JavaScript. And then you process your styles. And then if the browser has to assess whether or not your layout shifted. And then if your layout shifted, it processes all of that, goes through the layout, that's there. And then it goes through, this is compositing, and then, or that was painting and then compositing. And then when all that happens, like this is everything that's happening. This is your 16 millisecond budget. That whenever you're going for your like 60 frames per second, you're hitting this. And sorry, that's the Moto G-ish. But like this would be your iPhone. You're rendering in 5 milliseconds, you refresh your page, like boom, cool, I'm there. Yes, cool, great experience. Those are your flagship users. Here's the Moto G. We're getting a little closer. Like it does okay. It's fine. This site's probably a little Hello World site. But this Moto G, it's getting very close to that 16 milliseconds for load. Then you have other devices. Like that Nokia feature phone. We're way over budget now. We're not rendering at 60 frames per second anymore. This 60 frames per second budget is insanely important. And this is on a 60 hertz display. So whenever you're rendering on a 60 hertz display, you have very little time to really focus on JavaScript, because JavaScript is the variable thing in there. You don't know how much you're going to have. In a React app, you're going to have a majority JavaScript because they use a ton of JavaScript in React. Same thing with all those other JavaScript frameworks. You're going to use JavaScript. And it just keeps growing. 90 hertz to screen, 90 hertz display. Your budget is now a little over 11 milliseconds. Does anyone know why? Higher refresh rate. So you have these higher end devices that are shipping with higher end screens that have higher quality screens, but they have lower processors. So how do we combat that? Screens are getting way, they were ahead of processors like for a long time. I think it's a little better now, but then you have 120 hertz displays on like the new iPads and like some computer screens. And look at that. I mean, haven't even done processing JavaScript yet almost. You know, there's gaming laptops that also process at 144. That were 7 milliseconds. You have 7 milliseconds to do everything the browser needs to do. A little ridiculous, right? So all this JavaScript now is hanging, and your page is literally frozen. You can't do anything. So what do you do about it? Well, I mean, this is a French fry. And this is a straw shoving into the French fry. And the browser is now bleeding inside because you just made the French fry explode. The French fry is literally brittle. You can't do anything with it. Like it's not meant to have a straw going into it. All your code is trying to go into it. And I made this depiction at a happy hour one night with too many drinks in me, and someone was like, dude, you have to put that in your talk. And I was like, AI generate French fry going into, or straw going into French fry. Don't ask me what those images were, because this was the cleanest one. So you're not wrong, by the way. You aren't wrong. Everything you've been doing, anyone that's not using Workers, you are 100% doing what the norms are. Our web is built around the main thread. So we're going to talk about multi-threading, and then we're going to dive into Workers, because Workers is essentially multi-threading. Multi-threading in other languages looks very similar to, I mean, if you've done Swift at all, you have the dispatch queue, and it handles multi-threading because this is what like iPhone apps are built on, what Mac OS apps are built on. So you have the dispatch queue, and it's like waiting for events to happen, and it offloads to other threads. You have like Unity apps. Man, that is not loading on that display, but it loads on mine. There you go. Okay. They need Workers. So in Unity, you have jobs. It's the job queue. It's very, very similar. They all have like a similar mindset, a similar language. You're basically offloading an event. That event goes on, and you can go about your way, and you process all your other JavaScript synchronously. And then all those other things, it just happens on a main thread. It sends an event back, and then you process the event, and that event does something, and then it changes something in the queue, and says, I'm done. And it may take milliseconds. Like it may not take any time at all, but it didn't block the process from happening. It didn't happen step by step. It went and put it back in. All right. So what is a worker? After all this, does anyone know what a worker is yet? Anyone? Please, someone answer. A thread. All right. So there's a few types of workers. You have web workers, service workers, shared workers, and they're different from worklets, but not dissimilar. Web workers, basically in a very basic sense, that's what I'm gonna talk about the most today, is a web worker runs when the instance of the browser or the instance of your website is running in that moment. So you offload something to a worker and it comes back, sends an event back, and you're done with it. You can throw it away, or you can stay running and you can send other events to it, whatever. But when you close your website, it goes away. Service workers load into the context of the browser. So in browsers like Chrome, where it runs kind of in the background, and you get a Google Calendar push notification. That's because the Google Calendar has like a service worker that loads into the context of your browser, and it knows like, hey, he allowed notifications or they allowed notifications, send a notification through. And then it gets a desktop notification, and that's how that happens. Because it's running a service worker that sends a message, and then boom, and you get everything works. Shared workers are essentially shared web workers. I'm not going to talk anything about those today. However, there is support with them in all browsers. And by the way, all these have had support since 2012 in at least Chrome. Shared workers took a little longer for Firefox and Safari because, well, Safari is the new IE. And if you know, you know. The web workers have been a thing since 2012 though, and very widely available. They were actually introduced into the browser in 2007 in all major browsers, and then slowly support came, and I mean they're very stable. Worklets are different. If you went to Jonathan's talk today, it was like one of the first talks. He talked about like an audio worklet. And those actually run in a different browser process as a worker, but they're specific to their task. So like an audio worklet is specifically for audio tasks, or you have like a rendering worklet that is specific for like rendering tasks, but they're a little different. Web workers, you can actually put code in and do stuff, and then like, I'm cool, I'm multi-threading. Web workers are, I think I already said this, but they're a background task. They run in a separate thread. It can improve speed, not guaranteeing a speed improvement, but it can. And they're very CPU intensive tasks. That's what they're designed for. And there's no presentation layer associated with that. So what's that mean? Well, hang on. I had a slide there. Redone this 3 times today. So no presentation layer. So meaning you don't have access to the DOM. There's no document. There's no window. So document.getElement by ID. You have to do that on the main thread. There's no instance of the window to be able to map to like a global object. So if you're using global and you try and actually pass that in, it's not going to work. There's other things that work in there though. And the available functions list is quite long. It's all like major JavaScript functions. So from the background fetch API, console API, Canvas, and that's actually newish. Canvas used to not be able to copy into a worker. IndexedDB, that one's important. IndexedDB is the only way you can actually communicate back and forth. And I say that as I'm looking for local storage. No, you cannot. So local storage, session storage, you cannot access that in a worker context. In order to share state between workers, you have to access the IndexedDB store. If you're choosing to do that, I don't do that very often because IndexedDB is a beast to work with. Notifications API, payment handler, push API, URL API, then all these like web crypto, web locks, web serial, web codecs, web GL, web GPU, web sockets, blah, blah, blah. The list goes on. They can also implement the worker navigator. So you have access to like what Jonathan did earlier with audio worklets. You can access that in a worker. Worker location, global scope. It's the worker global scope, so it's access to all the worker global functions. Okay. So when you're introducing a worker in your project, let's say you have a legacy project that is running slow and you're like, maybe I want to do workers. Some low-hanging fruit you can obviously kind of reach for. The first one comes to mind is fetch. This is a really easy one to wrap your brain around, especially if you're an Angular developer or you are used to like separating your code into like single responsibility. You have a service layer in Angular where you have like service injectable or whatever, and you can only do like data fetching in a service. That's a great instance for a worker. Just remove the service altogether. or make your service talk to a worker, then like if you're Angular and you want to do like the ng web worker or whatever, you can actually interface with fetch really easily and then offloads that task and it's not blocking. On top of that, because now you're fetching data from an API, you're doing array iteration and you're having to like map arrays because your backend team sucks and they send you an object that's like 3,000 things and you need 2 object items from it. It's worse. You can do array iteration in there, get what you need, and then send it back, and it's like that your UI is fine. Heavy tasks that impact your UI rendering. So these tasks are like canvas. You can render different things in a worker in a string, for example, and then pass that string back and then parse it back, set the type, and you can do a little bit of that in a worker within reason. Array buffers are important. That's really common in a web worker. I think I said that already, but like if you're rendering PDFs or you're parsing through like an image format and that image comes back to you as a blob and then you have to like expand that, put it into an array buffer and then send it off to a WASM worker or something to do its thing and then it sends back, then you get an actual response back that's a blob that your browser understands. That's one thing. WebGL, gaming. Those things are really, really great. Okay, the code. So to implement a worker, it's really easy. On message. This is on the main thread, and this is also in the worker thread. And when I say worker thread and main thread, let's just, for the sake of this, say main.ts and worker.ts, okay? So on message, basically, you're waiting for an event. And as part of the worker global scope, you're introduced to this on message function. Workers just know what this is, and they can send messages to this. And this is how you'll send messages back and forth from the main thread to the worker thread. And the message event type, this is fully supported in TypeScript, by the way. Message event, usually you won't do much with the rest of the event, but message.data is where your data will go and accepts a generic type. You can pass in custom types to it if you want, so that your data object is then strictly typed within your type system. On the main thread, you would do like myWorker.postMessage. And this basically, hey, I'm going to send a message to it. So this, in the scope of like Swift or Unity, it's like the job queue basically, or the Swift dispatch queue. You're essentially post messaging out. And what this does is it uses that instance of the worker, and the worker does work and comes back to the on message that I showed before. And self.postMessage, self sometimes isn't needed. Some people do it for implicitcy. But in a worker, you'll do post message to send a message back to the on message listener in the main thread. So basically you have an on message listener in the main thread and the worker thread, both listening for messages back and forth. Because workers are in a completely separate thread in a completely different context than the main thread. Like the main thread doesn't know anything about a worker other than, hey, I'm sending messages to you, send something back. It's like sending messages to your grandma and she never responds to you, then she sent you $10 for your birthday. Finally. So basic vanilla implementation of a worker would be like in the main thread, you would create a new instance of a worker. It would say use new worker, use the worker constructor, and you pass in the URL to your worker, and you can say import meta URL, so it keeps the context of the worker. And it's just the relative path to your worker. It just knows how to handle it. And then this do something is, that's wrong. Oh, no, this is a function. So like you would create a constant, like a function or something like that, and your post message would execute my worker from here, my worker.postMessage, and you would send data. Whatever that data is, you can send anything to a worker. It can be a string, it can be an object, it can be an array, it can be array buffer, it can pretty much take anything and the worker decides how to do it. A basic example of a worker, like inside of a worker, this would be like worker.ts, whatever you sent over here. You would get this message here, and that message.data. Message.data you would then call getName and pass the name into this string, or into this function as the method signature. And then this has a switch case going on. I'm doing a match on Quin, and I passed Quin in, and I would return my name, Carter, and it would send a message back. If it was the wrong name, it would say no name. Pretty basic. this is definitely not, it's like scratching the surface. But notice I didn't do a return there, I did a break, and I did a post message. So I'm posting that message back to the main thread, and then the main thread will listen to that, and then fully understand how to actually consume it. And this is a lit implementation using a worker. With lit element, it's a web components library based off Polymer at Google. They open sourced it, it became lit if you don't know what lit is. Very, very cool, it's web components. Anyway, so notice up here I am doing some cool worker, and then the path of the worker, this is on the main thread, and then I'm creating a new instance of that worker. I'm doing it a little different though. This is some beat magic, and I'll show you the beat magic like extracted in just a second. But just ignore that for a second, and I'm setting the name here. I have a connected callback, which is like ng on a init, or like component will mount or component did mount in React. Very, very similar, those two functions. And I'm calling the super. And then in this message here, I do my worker.onMessage. That's important. So the my worker instance that you see up here, I'm using that instance and I'm saying when this worker sends a message back, do something. And what I'm doing in this instance is just setting the name to whatever the response is from the data that you got back from the worker. In this instance, it's a string. I know it's a string, I didn't type it, but probably should have for the demo, but it's okay. I wrote this 3 times today. And then that's what typing in connected callback. But on first updated, this is like ng on changes or like updated in React or whatever, or use effect in React, I guess now. Whenever first updated gets called, it only gets called one time. And my worker.post message, I'm actually sending my name to the worker here. And because this happened whenever the component connected and the connected callback, it's already waiting for a message, but then first update gets called. This posts the message back to the worker that was on the previous screen, and I get a message back, and then it updates the variable, and then it puts the variable here on the template. Okay, this is another basic web worker implementation with a fetch. This is actually calling the Harry Potter API. So really cool API, by the way. If you want to know anything about Harry Potter, it's just it was random. I found it on like cool APIs. So I'm calling in my on message event, I'm calling get houses. And in a worker, you can do a few different things. And I'll dive into this in a minute when I actually show some other code. But you can actually create multiple functions in here, and you can call the same worker, and a worker can have multiple of the same tasks. Like let's say I wanted a Harry Potter worker, and I could get houses, I could get people, I could get spells, I can get all the different things, and I can create different functions for that, and then use some sort of mapping in my on message to call the right method. But there's an operation in there, and that gets kind of complex. So the adoption here, I get why the adoption's been slow. It's because the way you communicate with workers is like really not there. There's libraries out there that help you fix it, like Comlink, and I think there's another one out there that does a better job. Comlink, I had issues because it didn't bundle with Vite correctly, but I think it does now. So this is the house worker on the main thread. It's just rendering the houses. I'm not going to go through that again. The honorable mention for React, because we had React devs in here. React does not really make workers a first-class citizen, and you have to use use effect, cringe. So I know use effect is like has lots of side effects, and if you don't pass in the right dependencies like I just did here, you're probably going to have a bad like memory leak or something like that if something happens. So make sure you always pass in your dependencies. So I do the same thing here, where I'm creating an instance of the worker as a use state variable, and this is my worker right here, and I'm listening for a message in this use effect. I'm updating like set result. I'm updating the data from a use state variable, and then I am actually terminating my worker when I'm done with it. And that's important for later. I use that a lot in my code for my demo, which brings me to workers spawning workers. Workers can be multi-layered. Anyone know that? So like I could create a worker that spawns 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 a worker and comes back and comes back and comes back and comes back and comes back. And then you get data from all those things. There's a good separation of work if you do that. For example, in my demo I'm going to show in a bit, I had to call like 3 APIs to get one set of data and build it because I don't own the API. And probably should be happening on a BFF, but wanted this to be client side. Flex. There are concerns with this like memory. So you could, if you're not terminating workers, you could introduce some sort of memory leak if they continue to run, which I had browser crashes all the time when I was building my demo, and that's what makes me come to this. So here is an example, and please don't use this code, but it's a way you can spawn workers. And I'm doing this, I'm calling the Track TV Movies API, and this is code for my demo that I'm gonna show later. I'll show the code and the repo later. But basically I'm calling the Track TV API to get a list of movies and the people in that movie. Because the initial API call that I call does not actually get the people data, it gets their ID and their name. That's it. I don't get their picture, I don't get any additional info about them, and I need that for my app to work. So I create a map on the cast, and I create a new instance of this person worker, and every time this array iterates, it creates a new worker and goes and does work on the side. And then when it's done and it gets data back from the person worker, it doesn't spawn another worker, it just gets a person, posts messages back, and when it posts messages back to the previous, it terminates. So it's going to terminate the worker, but not before post messaging back to the original worker that called this, which then builds my array, and my array is basically going to render images of each cast member as it comes in without blocking the thread. Okay, and I'm going to jump into micro frontends. This is a huge topic. I could have a whole talk on this, but I'm going to scrape the surface, and I'm going to try and introduce some learnings that I had and why this is important. With micro frontends, you introduce a lot of problems with users where you're trying to load a bunch at the same time. So if your front end is loading multiple micro frontends on the page at the same time, think about you're loading your host application that is hosting all 7 of these micro frontends, and this host application is running on its own thread. It had to render those micro frontends, which then those things have to render, which has JavaScript and styling, and everything else has to render on top of it. So the only thing you can optimize is the JavaScript. Everything else is handled by the browser. You can also minify your code and stuff too, but like on a platform I worked on, without saying names, we were running 17 micro frontends, and they were all in web components, but basically I had to assess the problem. We had major thread locking. And I knew workers was the instance that you were supposed to like create, but I couldn't figure out how to do it because micro frontends have an inherent problem. You can't actually instantiate a worker from an origin it's not from. So when you do import meta URL, it's actually going to retain the origin from where it came from, and you'll get an error, a type error, which on this slide, I think I'm covering it up. But you get import meta URL, blah, 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 worker from this origin cannot be loaded because cannot load the worker constructor from a separate origin due to security. It's a browser lock issue and it's unavoidable. So I went down a rabbit hole and researched, and in the end, I came up with a solution. And we had multiple MFEs in the same SPA context, different workers. I already said this. My slides were out of order. I'm sorry. This is the error. Sorry. That's the error you get. Cannot be accessed from origin, whatever. This was something I pulled off the internet, but that's basically the DOM exception you get. How do we fix this? Solution exists. So this was the Vite magic I was telling you earlier. You have this some cool worker and then path to worker. And then Vite has this syntax at the end where you're basically passing in a query string where you say, I want this as a worker, but I also want it inline. So the power of this is whenever you pass something as inline in your micro frontend, it now becomes part of your final bundle. And if everyone knows about micro front ends, all you're doing basically is importing a script tag on your host application and then loading the web component page. And then it loads from that final bundle. So Vite knows how to bundle this in line, which is really, really cool. And it solved the problem of workers in micro front ends, like with no brain at all. All I did was just pass in line, and I was already passing worker, and it was just a really, really weird situation where I didn't know about the value. The config for workers in Vite, this is optional, but the default is IFE, and if you're still doing IFE in 2025, you should stop.
Don't hate on old school, man.
Does anyone know what IFE is? Okay, cool.
Yeah, millennials do. What's up?
Cool people. No, it's an immediately invoked function event, or a function, immediately invoked function
Expression.
Yeah, thank you.
Okay to forget.
And basically, every time the browser runs, it re-invokes it. So every time your micro front end or your worker hits the page, it's like, I'm going to re-invoke this, even though when you use ES module, it's stored in the ES module scope. So in summary, you want to focus on the user, follow Rail guidelines, because that's important. That's really why we're here, is because our users, we want people to use our stuff. If we don't want people to use our stuff, then why are we building it? I mean, maybe you're solving a problem at home and you don't care what it looks like, but most of us probably work for people that want to build something that is scalable and looks good and feels good. Workerize as much as possible. Here's a little demo. And I built this site just for this. And basically, this is running a couple different APIs, but uses workers. And the Pokemon API, if you've ever worked with it, Poke API, it does some fancy stuff with, it does some fancy stuff. I want you to watch real quick on the sources page right here. I'm actually, excuse me, I'm gonna clear this. Watch my sources when I load this. You're gonna see workers just like spinning. So all of my workers just go whoosh. And now you're gonna watch them go as they receive data back. And then now this is just rendering the images. This is more basic, okay? The tracked API I was demoing earlier, a little more advanced example of worker implementation, because I'm doing a little more on here. And so this one, it's actually a little more efficient because I coded it better apparently. But this is without any throttling on, I think. Was I throttling just then? No, it was not. So that's with no throttling on. And this is a very basic thing. It's according to the track API. I can see like Moana's trending right now. That just happened was getting the people. And I'm doing something kind of cool with the people if you weren't aware that when I scroll, it's actually loading the images on the fly. So I'm doing lazy on that, better user experience. In here, actually I was doing throttling a little bit. So in the browser itself, I'm going to scroll this over. In the browser itself, you can actually set this performance for on your network tab to slow 4G and 3G. I'm on slow 4G right now. In the performance tab, this is where I live. You can set CPU throttling. I'm going to throttle it. I'm not going to do 20x because I don't want y'all to be here for an hour. But where's my application? I'm going to clear my site data, and we're going to go back to sources here. Actually, I think I have to be on performance for it to register, maybe. I'm going to refresh my page, and this is a clean site. So notice this is like still rendering the page, but I'm not thread blocking. I was still able to click. This is not going to load very well right now because I'm slow, but interactivity's there. And I'm meeting my rail budget too, where the site is loading. And like now, I mean, the full site's loaded. You couldn't tell because I'm scaling in and I'm mobile responsive because I'm a front-end developer. So whenever you actually render something, I'm actually caching stuff too. So if I click on a movie I've already clicked on, like now if I go back to, I don't know, what did I click on?
Mickey 17.
Oh, Mickey 17? Okay. So if I click on a movie I already clicked on, it's actually stored in local storage. And this is where I said I probably needed to use IndexedDB, but I was literally pulling my hair out on Wednesday. Like, IndexedDB is so hard. If anyone knows IndexedDB and wants to give me a crash course, I was trying IDB keyval. I was trying to interface with IndexedDB directly. It is the biggest pain in the butt you'll ever work with because you have transactions, you have everything, but like IndexedDB is the future. Like you should be using IndexedDB because it's workable in a worker and it's not blocking. And it has higher limits than local storage, which if you run this for any time at all, you'll hit those limits and you'll get a Chrome, oh snap, because I hit my local storage limit. Because I'm loading too much data into my local storage because I'm caching like everything as much as I can. For the sake of the demo though, I did local storage. Other considerations, I know JS libraries, like if you're a library author, some things you don't want to bundle. You want to leave that up to the end user, but if you're a library that's sending a single bundle to someone, like, I don't know, Shape, calling them out if you work for Shape, go workerize your stuff because it's thread blocking. What's another one? I'm just trying to think, like New Relic, they actually post a script that you can, they host a script you can use, doesn't run a worker, but they only host a single bundle. And there's like multiple things. If you're sending a single bundle or you're expecting your users to add a single bundle to your script tag and you're not deferring it, it will thread block your site. So as a JS library, it's your responsibility to deliver good experiences to your customers. This doesn't just apply to people working on apps. You have to build for everyone as a JS library author. Other considerations too, WebAssembly. I built a WebAssembly web component, or as a web component, and I used WebAssembly back in 2021 that used workers. And it was a fork of, or not really fork, I reverse engineered PDFium, which is Chrome's built-in PDF rendering library. And I didn't write this. This was something that the guy wrote. I found it after I had already reverse engineered it. I ended up using this too. But basically he compiles to WASM, but his demo site sucks. And I'm sorry, he's working on open source, nothing against open source, but he's obviously backend dev. I was proposing a web component to him for this PDFium thing. He's like, I don't have time to work on it. So I built it and it's not external, so I can't actually show you, but basically I benchmarked it against PDF.js with CPU slowdown at 6x and a slow 4G connection, passing the Apple acknowledgements for the iPad. 262 pages, 12 seconds on PDF.js, 5 milliseconds on mine. Processed every page on the fly. No thread blocking, I could turn pages very, very quickly. In the 12 seconds that it took PDF.js to load, I paged through the entire app, or the entire book. So like I was clicking really fast though, so. I wrote an article on multi-threading the web. If you're interested, you can scan that. I wrote it a couple of years ago, but it's still very relevant. I touch on workers a little bit. I touch on WebAssembly a little bit. If you're hungry for more, definitely reach out to me. I mean, my site, my portfolio site is quincarter.com. All of my stuff, like my phone number, everything is listed on there. I get contacted by recruiters that I don't know all the time. It's really annoying. So yeah, I think this was my last slide. Maybe. Yeah, it was my last slide. So I'll leave this up here if you're interested. It's very, very hinged on what I worked on, talked about in this talk. I go a little more into this talk than I did on that page, on that article. If there's any questions or anything, I'd be happy to answer, but I think we are over time, so I apologize. I made you late for having you.
I have one question.
Go for it.
Do all of the workers run on one thread, or do they like work on multiple different threads simultaneously?
So they work on multiple threads simultaneously. The disadvantage when you start to try multi-thread with an inherently single-threaded thing, especially on a mobile device, even though there's multi-thread scores, you usually only have 1 to 3 fast cores, and the rest are efficiency cores. So as you start to try and thread things up, if they're not fast, and it's not like fast computations, then it can slow down. It could be a performance degrader versus an increaser. But yes, they do spin up multiple threads. If I spun up the performance and ran it on there, you'd actually see like 100 workers spun up whenever I like instantiated the movies.
For the worker spawning workers concept, right? If a worker is off the main thread, then what's the benefit of spawning another worker from that worker? Like, would you block the thread that worker is on, like the main worker is on, and then want to like sub-thread that one out? Because like so is it more like a code organization kind of activities, like where you can like read about like parts of a really big long task? Because like it seems like if the goal is to not block the UI thread, then like you might just need one worker, right? Like one big giant.
Kind of. So this was a really weird instance where I thought workers spawning workers would kind of look cool because with this concept, I would end up calling another async fetch call, which would block inside the worker and it would take a slower amount of time. So instead of being async, I use map, which is synchronous. And those calls would all happen at a time. And then I would call a worker, which does a fetch call that's async. I wait for a response back. When a response comes back, I then terminate the worker, but I post message back to the main worker, whatever I need. And when I have logic in here somewhere, right here. If the message.cast.linked is equal to map.cast or map.cast with images.linked, then return back to the main thread with the full list of cast. This way I don't accidentally post message back, but you know, as I was creating this, I tried it where I could post message without that equals. And that was where I started noticing more issues because I was post messaging back too fast. So it kept writing to my console because I was console logging. If I wasn't console logging, I could probably get away with it, but it was filling up my console, which then made the browser think, oh no, there's a memory leak. And then it just kind of failed gracefully versus even though nothing was wrong. So you have to worry about that with multiple threads. You run into that with anything though, like you could create a memory leak.
Sure.
I would imagine it's significantly harder to debug when you have multiple threads. Do you have any tips for that?
Workers are really easy to debug from DevTools actually, especially when they're bundled with V, and you're running them on your like Darn Start or NPM Start or whatever. You can. There's also ways to do it in VS Code, but you can create a breakpoint in a worker that you know is getting called, and it knows where that breakpoint is, even though it creates a new instance of the worker. The class inside of Chrome or the file inside of Chrome is still the name of the file that you have. So the breakpoint is in the file, not the worker. Cool. Thanks everyone.